Almost 40 years ago, scientists discovered that human activities were depleting the ozone layer. Because of that, a hole had formed over Antarctica. These discoveries brought the world together to tackle an environmental challenges for a lifetime. What is ozone? Ozone is a highly reactive gas that composed of three oxygen atoms. Ozone is mostly found in the stratosphere, a layer of the atmosphere between 10 to 50 kilometers above the Earth's surface. This ozone layer forms an invisible protective shield over the planet. Sun emits ultraviolet radiation directly towards the Earth. This ozone layer will prevent the UV rays from entering the Earth's atmosphere, which will cause severe damages for life. Without ozone, life on Earth would not be possible. Man-made industrial chemicals disturb ozone molecules. These substances break down ozone molecule by stripping away one of the oxygen atoms. Over time, this reaction can make the ozone layer less stable. By 1984, the ozone layer over Antarctica's Halley Bay Research Station has lost one-third of its thickness compared to previous decades. Jonathan Shanklin with Joe Fairman and Brian Gardiner published their findings that the link to human-made compounds called chlorofluorocarbons reached the stratosphere and disturbed the ozone layer to the point of depletion, commonly known as ozone hole. This hole formed at the South Pole due to the region's unique meteorological and chemical conditions. Scientists pinpointed the emission of certain gases containing ozone-depleting substance as the main source of the problem. CFCs, known for chlorofluorocarbons, are one of the most dangerous gases to the ozone layer. CFC contain chlorine, which is used to killing bacteria in the swimming pool, but its gaseous form is harmful to the ozone layer. CFCs were widely used in previous decades, peaking in the late 1980s. Many refrigerators, air conditioners, and foam blowing equipments used to emit dangerous levels of chlorine gas into the atmosphere. Once chlorine reaches the ozone layer, ultraviolet radiation from the sun converts it into a reactive substance which then destroys ozone molecules. Other compounds such as bromine have also played a role in depleting the ozone layer. Even though levels of these substances in the atmosphere reduced drastically over the years, the ozone hole will only fully recover in coming decades. Ozone layer thinning is a human health risk. That's because more ultraviolet rays from the sun can pass through the layer and reach the Earth's surface. Excess UV radiation is particularly worrisome as it can cause skin cancer and cataracts. UV radiation also can harm marine life and plants and reduce the productivity of rice, wheat, and soybean crops. The effect of CFC might go beyond the ozone layer. CFCs are potentially greenhouse gases and could cause a broader impact on climate change outcomes. CFCs are found in relatively concentrations in the atmosphere when compared to carbon dioxide, so they are considered a minor player in global warming. Recent research has shown that these same gases have spread up over the Arctic, contributing to a sea level rise and surface warming in the North Pole. In 1987, the Montreal Protocol was adopted to protect the ozone layer by phasing out the chemicals which depletes it. Compliance with the treaty is common, but different responsibility scheduled for developed and developing countries, and established a multilateral fund to provide financial and technical assistance to help developing countries who meet their obligations. During 1990s and early 2000s, the production and consumption of CFCs was brought to a halt. By 2009, 98% of the chemicals agreed to the treaty to replace CFC with hydrochlorofluorocarbons HCFC and hydrofluorocarbons HFCs. While good for the ozone layer but bad for the climate. The global warming is potentially caused by HCFC gas. For example, it is almost 2000 times stronger than the carbon dioxide. The Montreal Protocol has been signed by each and every country in the world. This is the only treaty to be universally ratified. As a result of Montreal Protocol, concentration on ozone depleting gases in the atmosphere have significantly declined. But according to environmental physics professor at the University of Canterbury, the issue isn't solved yet. As long as the ozone will continue to form each winter and spring, I don't think we can say the issue is fixed. We need to keep monitoring the ozone layer to check that it is recovering from the effects of CFCs, she says. Further research by environmentalists showed that the recovery of ozone hole could be delayed because of this emission. But after Montreal Protocol, ozone is slowly recovering, but it takes decades to back to its normal level. Countries continue to abide by the Montreal Protocol. Climate model shows that ozone level should return to standard measure by the end of 21st century. We need to be vigilant about following the Montreal Protocol. Even one country flouting the rules could delay ozone recovery substantially. Thank you for watching our videos. Please subscribe our channel for more updates.